Let's build a personal expense tracker together. Notebooks or Excel for expenses can feel boring or generic. Build your own local tracker that saves your data safely every time you use it. This is what we're building. We're building a simple local expense tracker that lets you add, edit, and delete expenses with descriptions and amounts. It saves all your data to a file on your computer so your expense history is always available every time you open the app. No paper, no spreadsheets, just your personalized, persistent expense manager. Let's take a look at the class diagram. We have three primary classes: Expense Tracker GUI, Expense Manager, and Expense. First, Expense Tracker GUI is the graphical user interface controller. It includes components like text fields for the amount and description, buttons, and a table to display expenses. This class interacts with the Expense Manager to manage the underlying data. Its main responsibility is to handle user input and display the information accordingly. Next, the Expense Manager class acts as a data handler. It maintains a list of expense objects and provides methods to add, remove, and update and retrieve expenses. Importantly, this class has been extended to include persistence methods like save to file and load from file. These methods serialize and deserialize the list of expenses to a file, allowing the data to be saved and reloaded between application runs. This addition keeps the GUI code simple while managing data saving and loading in one place. Finally, the expense class represents a single expense item. It contains two attributes, the amount and the description. It also includes getter and setter methods. Note that expense implements serializable, so it can be written to and read from files using serialization. The relationships between the classes show that Expense Tracker GUI uses one instance of Expense Manager, and Expense Manager composes of many expense objects. This design cleanly separates concerns with GUI, business logic, and data representation, each in their own class. Overall, this diagram reflects how your application handles user interaction and manages expense data and persists it efficiently using a small tweak to the existing code. First things first, we have to create our package. So new package, expense tracker, enter, and now we're going to add our first class, which is going to be called expense. Let's get to the code. First, the package declaration groups the class logically within the project, helping to organize code and avoid naming conflicts. Next, the class imports serializable interface, which allows instances of expenses to be saved and restored, for example, by writing to a file or sending over a network. This class itself implements serializable and declares a special unique identifier called serial version UID. This ID plays a crucial role in serialization by confirming version compatibility when serializing and deserializing objects, protecting against runtime errors if the class structure changes. Two private fields follow a double called amount, representing the monetary value of the expense, and a string called description, which provides a textual explanation for the expense. These private fields embody the principle of encapsulation by restricting direct access from the outside of the class. To create new objects, the class provides a public constructor that accepts an amount and a description as parameters, initialing these fields accordingly. The class then provides public getter methods for both fields, allowing safe read access to these private variables. Similarly, public setter methods are included to modify the amount or description if needed after creation, still maintaining control through method calls rather than direct field manipulation. To summarize all this class blends core object-oriented principles like encapsulation with practical features like serialization readiness. It follows Java conventions, making expense object easy to use, modify, and store, which is essential for managing expense data in applications. Now it's time to create our second class, which is, by the way, Expense Manager. Let's create the class. Start with the declaration of the class, public class Expense Manager. This line defines a public class named Expense Manager. It forms a core blueprint for managing multiple expense entries. Next, we declare a private variable called expenses. Here we're creating a list called expenses to hold multiple expense objects. The list is marked private to restrict direct external access. Moving on to the constructor, we're going to have the constructor called Expense Manager. This is a constructor method called when we create a new expense manager object. Inside, we initialize the expense list to an array list. This line creates an empty dynamic list ready to store expense objects. The next method is to add an expense. So here we have public void add expense, which takes an expense to add it to our list. This public method takes an expense object as an input. Within it, we add the expense to the list. So expenses.add expense. This appends a new expense to our list, expanding our records. So first we have to import this to our project so we can import. So we imported Java util array list, Java util list, and we're good to go. To remove an expense at a specific index, we have the remove expense method. We accept an index number and first check if it's within valid bounds. So if index is greater or equal to 0 and the index is less than expenses.size. Then this ensures safety, preventing errors from invalid indexes. If valid, we remove the expense from our list. This deletes the expense at that position. To update an expense at a given position, we have the update expense method, which takes an index and the expense itself. Similarly to the previous one, we verify the index if it's valid, and if yes, we replace the existing expense with the new one. So it's going to be expenses that set index and that expense were received. Now, to retrieve all current expenses, we have get expenses method, which returns a list of expenses. Rather than returning the internal list directly, we return a new copy. Return new array list and the copy of expenses. This returns the copy. This avoids external code accidentally modifying our internal data. To calculate the total amount of all expenses, we have the get total expenses method. We initialize a total accumulator, so the total is set to 0. Then for each expense in the list, we use a for loop. We add its amount to the total. So the total is going to be plus equals expense.getAmount. Finally, we return the total sum. For saving expenses to a file, we use this method here, save to file, which takes a file name. Inside, we open a stream to write objects. We have try with resources, and we're opening a stream, object output a stream, and give the file output a stream to it with the file name. Then write the entire list to the file with the name os.write objects and pass in the expenses. If an error occurs, we print the stack trace for debugging. Here we have catch and the IO exception, and then we are printing the stack trace and then we can debug it perfectly. What remains is importing these classes to our project with the import button here, the IO exception, and we're good to go. Similarly, for loading expenses from a file, we have load from file, which takes a file name. We open a stream to read the objects, like the try with resources here, and then we read the list back and cast it appropriately. So it's going to be expenses and then cast it here, and we're gonna read the object, and then if the file doesn't exist, we start fresh with an empty list. Here in our catch, we have an empty list, an empty array list, and other exceptions are also caught and printed. Then we also initialize an empty list to keep our program stable. So here the catch, we have I exception, class not found exception. We have printing to the stack trace for debugging purposes, and here we're having an empty list. Finally, we close the class with a closing brace. What is left is to have object input stream for reading and file input stream, which we pass into our object input stream imported to our project. The annotation suppress warnings unchecked is used in Java to tell the compiler to ignore warnings related to unchecked operations, specifically those involving raw types and generics where type safety cannot be fully verified at compile time. This often occurs when casting or dealing with legacy code that uses raw collections. Using this annotation helps keep the compiler output clean by suppressing these specific warnings in the annotated code block, allowing developers to focus on more critical issues. However, it should be used cautiously because it hides warnings that could potentially point to problems in the code. Let's create our last class, Java class. We're going to call it Expense Tracker GUI and hit enter. Now that we have our Expense Tracker GUI, we can start coding. First off, I want to start by importing the important packages and classes that we are going to need for our GUI components and layout. So here are imports. We have swing, AWT, IO, and utils, everything we're going to need for this class. Second, it is important that our class extends JFrame to create main application window. So our Expense Tracker GUI is going to extend JFrame. Next up is defining fields for text input and expense table components. So we're going to have text amount. We're going to have the text description. The text amount is going to hold the amount we spent. The text description is going to hold the value for what we spent that money for. And the next one is going to be table model, expense table, and expense manager. Now we get to my favorite part, the constructor, which is going to initialize the UI and load the data. First off, we have our coding block, so the Expense Tracker GUI, and then we start coding. We instantiate Expense Manager to handle expense data and load saved expenses from file. So it's going to be Expense Manager, new Expense Manager, and load from file. And here we have the file which loads saved expenses if exists. In the previous part, I told you that if you close the program and open it, if you don't have a persistence logic, you're going to lose all the data you previously entered, and you're gonna lose all the data you want, but if you keep it on a file, you can then read it from the file, serialize, deserialize, and then you're doing this with no database. So I think for now, for what you want, we don't need a database, and file can handle it perfectly. Then we are going to set window title, size, close behavior, and center on the screen. So we have the title, expense tracker, we have the size, it's going to be a width of 600 and a height of 400. We have the default close operation, exit and close, and then we have our set location relative to null. So now it's time to create a panel to hold input fields and buttons using default flow layout. So JPanel, the JPanel is going to be called input panel, and new JPanel, we're creating an instance of it, and then we're going to be adding label and text field for amount entry, setting field width to 10 columns. So we have input panel, add new JLabel called amount. Then we're going to have the text amount equal to new text JText field, and we're going to have it to be 10 columns. And then we're going to add the text amount into our input panel, so the values that are going to be entered. Then we are going to add label and text field for description entry with is going to be 15 columns. So input panel, add new J label called description. The text description is going to be equal to a new J text field with 15 columns, and input panel text description is going to be added to our input panel. And now that we're done with our fields here, we're going to create buttons for add, edit, delete, and summary functionality. So we have add button, edit, delete, and summary, and we're doing all this by using J button and the summary. And when we do this, then we're going to add all buttons to the input panel. So again, we have input panel, add, button edit, delete, summary, and then what we're going to do is that we're going to create a table mode 1 with 2 columns, amount and description, and override is cell editable to disable editing this directly in the table. So we have the table model. New default table model is going to be a new object, a new array of objects of amount and description, and the row count is going to be 0. Then we're going to have this line of code here. So public boolean is cell editable, int row, int column, return false. This is going to return false because we're trying again to disable editing directly in the table. And now that we're coded this bit, what we're going to do is that we're going to create a JTable using the above model. So the table model we created from default table model. So expense table is going to be equals to new JTable given the table model. And then we're going to wrap table in JScroll pane to enable scrolling when we have many entries. So JScroll pane table scroll equals new JScroll pane, and the expense table is going to be passed to that. And then when we do that, next we're going to use border layout for mainframe, placing input panel at top and the table in center. When you saw what we're trying to do in the beginning, you can take a look at that to see the end result of what we're trying to design here. So we have the set layout is going to be new border layout. We're going to add input panel and border layout north, and then we're going to have our table scroll and border layout in the center. So now that we're done, we're going to add action listeners to buttons with Lambda syntax. So add button is going to call add expense and save data to file. So here we have button add action listener for our add operation. Then we're going to have add expense. We don't have the code yet. We're going to code this method right here, but after we're done with the constructor. And then we want to save the file, call expense manager save to file on our expense.ser file. So the save after the add. And now it's time for our edit button. So this one is somehow similar because we're calling edit expense and save file together instead of add expense and save file. So we have button edit, add action listener, edit expense, and expense manager that save file to the same file we're going to keep. And now it's time for our delete button. This button calls delete expense and save file. So another method we're going to code just in a moment. And so we have delete expense and expense manager save to file, save after delete. Now the last one is going to be having an action button for summary to display total expenses. So the listener for the summary. So button summary dot add action listener, and we're going to only show the summary. And then when we're done with all that, we're going to load data into table for initial display. So we have the refresh table method. We're going to code this one too. And we want to make frame visible on the screen. So we call set visible to true. Now let's add our first method. So it's going to be private void add expense method. What we're going to do here is that first we're going to grab the text the user typed into the amount field. So we have amount string text amount get text trim, and trim removes any extra spaces at the start or end, so it's clean. Then we're going to do the same thing for the description field and grab the description the user entered. Now we have two strings. We have amount string and description. Then we're going to check if either field is empty. So if amount string is empty or the description is empty. If so, if they're empty, we're going to pop up a message dialog telling the user please provide amount and description. So we have J option pane show message dialog, and the parent component is going to be this object, and the message is going to be please provide amount and description. And the title is going to be input error, and J option pane is going to be set to error message. And then J option pane is going that error message shows it as an error. Then we return which stops the method so nothing else happens. What we're going to do next is that we're going to attempt to convert the amount from a string to a double. So we need a try catch here because we are casting, we are doing double that we are parsing the double from a string to a double. We're changing its type, and then if the user typed something that isn't a number like ABC, this will throw a number format exception. So we have this one. Then what we're going to do is that we're going to create a new expense object using the parsed amount and the description. Then we're going to add it to the expense manager, which handles storing and managing all the expenses. When we do that, we're going to refresh the table so the new expense appears in the GUI. We haven't wrote the refresh table method yet. We're going to code it as soon as possible. And then after we refresh the table, we're going to clear the input field so the user can type the next expense. They're going to have more than one expense. And then when we wrote that, we're going to catch our exceptions. I told you that we're going to get a number format exception if anything goes wrong here. So if parsing the number fails, we're going to show a pop-up error invalid amount, and this prevents crashes if the user typed something wrong. So like we did with this dialog here, we're going to show an input error with a different message. Now let's code our edit expense error. What we're going to do is that we're going to get the index of the row that the user has selected in the table. So if the user has not selected anything, this line here is going to return -1. In our next part, we're going to check if we actually got -1 and the user didn't select a row to edit. So if that is true, we're going to show an error message, edit error message, and say select a row to edit. And then we're going to return because return stops the method so no editing happens. Then we're going to grab the amount and description from the input fields, and the trim here, like we said before, removes extra spaces at the start or end. Now we want to validate that both fields are filled in, and if not, we're going to show an error and stop again. So if amount string is empty, if the description is empty, I'm going to show an error saying please provide amount and description, and again return so that nothing happens. And then we're going to enter our try block. Here we're going to converts the amount string to a double, and if the user typed something invalid like letters, it will throw a number format exception. So double amount, double that parse double amount string is set. And then we're going to create a new expense object with the entered amount and description and call update expense on the expense manager, passing in the selected row index, so the existing expense gets replaced with new data. Like the previous one, after this we're going to refresh the table so the edited expense appears immediately in the GUI, and clear the input fields so the user can enter new data next time. Both for the amount and the description. And then we're going to catch the number format exception that was caused here if there's any problem. If the amount wasn't a valid number, we're going to show an error pop-up saying invalid amount as an input error. And this prevents a program from crashing due to bad input. And now let's code our delete expense method. So we have the delete expense method. We grab the index of the row that the user selected in the table to delete. We make sure that the user actually selected anything, and if they have not, we're going to show an error message saying select a row to delete, and then that this line returns -1 if no row is selected, and then we return so that the method stops. And next we go to our expense manager and remove the selected row and press passing the row index to our expense manager remove expense method. This removes the expense from the internal list, and then we again refresh the table. We update the table so the deleted expense disappears immediately from the GUI. Next up, we're going to code the show summary method. So we have the show summary, and then what we're going to do is that we're going to ask the expense manager to calculate the sum of all expenses. So expense manager get total expenses and the value is double. Then we're going to show a pop-up dialog displaying the total expenses we got from this method here, and it's going to be a summary. And in total, what we're going to do, the information message makes it look like a simple info box, not an error like we've done previously. And the last method we've been waiting for is the refresh table method here. The refresh table method, first of all, what we're going to do is that we're going to clear the table completely and set a row count to 0 because it removes all existing rows so we can reload the fresh data. Next we're going to get the current list of all expenses from the manager, and then we're going to loop over each expense and add a new row to the table with amount and description. So here we have table model add row, and here it's going to get an array of expense amount and the description. This whole method clears the table and reloads all expenses, keeping the GUI in sync with the data. Last but not least is our main method. This is the entry point of the program, and what we're going to do in this one is that we're going to call swing utilities that invoke later to make sure the GUI is created on the event dispatch thread, which is the correct thread for swing operations. Expense tracker GUI new, this part here creates a new instance of the GUI which will automatically show the window and initialize everything. We built a simple desktop app to help people keep track of their expenses easily. The main idea was to make it quick to add, edit, or delete expenses, and also to see a total of how much they've spent. The interface is clean and straightforward, so anyone can use it without a steep learning curve. We use Java Swing library because it gives us ready-made building blocks for windows, buttons, and tables, everything needed for a basic but functional program. Our app shows input boxes on top to enter amounts and notes with buttons to manage entries, and a table below to list all expenses clearly. Behind the scenes, we made an expense manager class to handle all the data stuff like storing the expenses in a list, calculating the total, and saving or loading data to a file so nothing gets lost when the app closes. This keeps the user interface focused just on showing and changing information, and the data management separate, which helps keep the code tidy and easier to maintain. We made sure the amount the user enters is a valid number and made the table not directly editable, so users can only change data through the input fields and buttons, avoiding mistakes. Every time you add, edit, or delete something, the list and table update immediately, so the app always shows the latest info. Overall, the project focuses on simplicity, clear structure, and ease of use, so anyone can track their spending without hassle. And that's our expense tracker app. Honestly, as a Java developer, most of the time you won't be building GUIs like this with Swing. What you'll more likely be doing is coding REST APIs, creating Postman collections to test them, and designing systems where front-end developers consume your APIs to interact with your data. In real projects, your code will usually be more secure, organized, and connected to a database for persistence. What I'm trying to do in these videos is help you get comfortable with coding and working through problems yourself. In the last video, I went line by line, but it ended up being really long. Writing everything down takes time. In this one, you can pause, try the code yourself, and experiment as you go. That's really the best way to learn. You can find the code in the GitHub repo linked in the description, but what really matters is that you open a code editor and type it out yourself. Face some questions and solve them either by asking in the comments or by searching online. That's how you grow as a developer. Please don't forget to ask your questions in the comments. Let me know what you think about this video. Hit the like button and please don't forget to subscribe. Goodbye.